These are the examples for Algebra 1B, Credit 2, Lesson 17.2. Lesson 17.2, we're going to be talking about adding polynomials. And so basically with adding polynomials, what we're doing is combining like terms. So what are like terms? Like terms means that the terms have the same variable and the same exponent. So for example, 8x to the fifth and 9x squared, while they have the same variable, they have different exponents. So those are not like terms. So what would be a like term with 8x to the fifth? Well, we'd be looking for another term that has x to the fifth in it. So we have x to the fifth, and we look over here, there's another x to the fifth. So 8x to the fifth and 10x to the fifth, we would consider, or we would call them like terms. So the first thing we're going to do is group our like terms. So we have, as we just said, we have 8x to the fifth, and then 10x to the fifth. And then as you do this, you can cross them out if it's helpful. You don't have to do that, but you know that you've already grouped those, and you don't have to worry about those anymore for grouping. So next we have, let's see, we have, that should be 11x squared. There we go. All right, so now we have like terms. We have a 9x squared here. And we also have an x squared over here. So we have 9x squared plus 11x squared. And so now we've grouped or collected, sometimes they call it, our like terms there. All right, so that takes care of those. Finally, constant terms. Remember what constant terms are? They're terms that don't have a variable in them. It's just a number. And so 1 and 1 over here would be like terms. So we have 1 plus 1. And now all we have to do is add up our like terms. So with the x to the fifth, we have 8 plus 10, which would be 18x to the fifth. With our x squareds, or x to the second power, we have 9 plus 11, which would be 20x squared. And then finally, a nice easy one here, 1 plus 1 just gives us 2. And so our final answer is 18x to the fifth plus 20x squared plus 2. Now let's take a look at an example for number 2. We've got a very similar problem here. The difference is we've made some of the terms negative. And so let's see how that affects what we do. So once again, our first step is to group or collect our like terms. So we have 8x to the fifth plus, 10x to the fifth. And then our x squareds, forgot to make that one an x squared. We have 9x squared plus a negative 11x squared. And then finally, our constant terms, we have 1 plus a negative 1. And again, if the signs, if you're like, well, wait a second here, what's exactly going on? Pause the video, make sure that you understand how we wrote this down. We are adding, so that's why that was 9x squared plus a negative 11x squared. All right, so combining our like terms, we have 8 plus 10, once again, is 18x to the fifth. But here, the signs are different. So we're going to subtract. 11 minus 9 is 2. So we have 2x squared. And since the larger number, 11, was negative, that's going to be a negative 2x squared. Finally, with our constant terms, again, the signs are different, a positive and a negative. So we subtract. But 1 minus 1 is 0. And so we just have a 0 here. And of course, we'd just say plus 0. But remember, 0 is neither positive nor negative. It's just 0. So we have 18x to the fifth minus 2x squared plus 0. But when we have 0 for either a coefficient or a constant term, we do not need to write that. And so our final answer here would just be 18x to the fifth minus 2x squared. And so that's how you would do number 2. All right, so let's take a look at an example now for number 3. And let's go ahead and erase all of this. And again, pause, rewind, study, make sure you got a good understanding of everything. And here we go. It says for numbers 3 and 4, model the situation with the sum. Remember, sum just means addition. So adding of polynomials or sum of polynomials, and then simplify their sum, and that would be by combining like terms. So it says the width of a rectangle is represented by 3x plus 5y. The length is represented by 7x minus 2y. Write a polynomial for the perimeter of the rectangle. All right, so let's go ahead and take a look at how we would do that. This is our example for problem number 3. And so in our example, our width is going to be represented by 11 plus 8y. Excuse me, yeah, 11x plus 8y. And then our width is going to be 10x minus 4y. Now, this is a rectangle, so opposite sides are congruent. They're the same. So if this is 11x plus 8y, so is this. And if this is 10x minus 4y, then so is this. And so now we're ready to set this up and combine our like terms. So what we can do to make this easier is from the diagram, we can just combine all of our x's and then all of our y's. So we have 11x and then another 11x and then a 10x and then another 10x. And so notice how we're just adding all of our x's up. In other words, we're grouping all of the x's together and then we'll add them up. For the y's, we have 8y and then another 8y and then a minus 4y and then another minus 4y. So careful on those signs. Make sure positives are positive, negatives are negative. All right, let's go ahead and add this up. 11 plus 11 is 22x. 22x, let's make that a little bit neater. 22x plus 10x is 32x. And then adding up that last 10x, 32x plus 10x is 42x. So adding up all of our x's, we get 42x. Now for the y's, we got to be careful because we do have some subtraction going on there. 8 plus 8 is 16y. And then bringing down our minus 4y, 16y minus 4y is 12y. And then finally, 12y minus the other 4y, 12 minus 4 is 8y. So let's go ahead and try and write that a little closer together over here. That's that answer there. And so our final simplified answer to represent the perimeter, remember, and I probably should have mentioned this as well too, perimeter is measuring the distance on the edge or the outside of the figure, in this case, a rectangle. So our final answer there, 42x plus 8y. Now, on number 5, it's very similar. It says a rectangular picture frame has the dimensions shown in the figure. Write a polynomial. Did I say number 5? Number 4. Sorry, number 4. Write a polynomial that represents the perimeter of the frame. Now, what's different there, instead of having y's, they just have constant terms. So what we're going to do is just do this problem again with constant terms there, but we're going to see that it's very much the same. So let's go ahead and see how that changes things here. And this is our example for number 4 now. So the x's, it's all the same, 11, 11, 10, and 10. So that's all going to stay the same. So that's all set up. Now, instead of all of these terms are just constant terms now, so we don't need the y's. So we have 8 plus 8, and then minus 4, minus 4. So again, very similar. Let's kind of center things, make it look a little bit nicer here. All right, so again, adding these up, this will be the same thing as the example for number 3, but just a chance to review it again. 11 plus 11 is 22x. And then bringing down the 10x's, 22 plus 10 is 32x. And then bringing down our final 10x, 32x plus 10x, as we already know, is 42x. So these are constant terms now, but still doesn't change really what much we do. But just to show you an example that's going to be similar to number 4, 8 plus 8 is 16. And then 16 minus 4 is 12. Then 12 minus that other 4 gives us a positive 8. So put that over there. And so we'd have 42x plus 8 would be our answer here. All right, so that is it. One other thing actually to mention, I want to take a look at one other possible variation. Let's make these 4s positive. going to see something like this, and it'll make the 8s negative. So what would that look like if the 4s had been the positive number? So that's only going to change what we're doing over here. So let's do a little what if. So we'd have -8, -8, and then +4, +4. And so let's see what that does to our answer. So -8, -8. So we're combining those. The signs are the same, so we still add them up. That's still 16, but they were both negative, so the answer is negative. And then bringing down our +4s. Here, the signs are different, so we subtract. 16 minus 4 is 12. 12, yeah, 12. There we go. The larger number is negative, so that's -12. And then finally, again, -12 plus 4. This again, the signs are different, so we subtract. 12 minus 4 is 8. We'll write that over there. And then the larger number is negative, so a -8. And so if that had been the case, then we'd have 42x minus 8. So a little bit of variation, as your problem is going to be something similar to that, where you will get a negative answer for the constant term there on number 4. All right, so that's it for the examples for 17.2. As always, pause, rewind the videos as needed, and I'm sure you're going to do great with the work. And until the next video, take care and God bless.